Problem 4, Stat3 2. The length in pages of math research projects is given below. Use this information. Calculate the mean and standard deviation. So this is for sample mean and standard deviation and population mean and standard deviation for the same data. Okay, mean formula for both sample and population is the same. All we do is add them all up, divide by the total number of numbers you have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are going to have a total over 9. Question is, what is that total? Well, I don't have to calculate separately. I'll just add it all up here. 21 plus 25 plus 23 plus 15 plus 28 plus 40 plus 21 plus 36 plus 33. Okay, so remember there is a parenthesis. Fill everybody in. You're adding them all up and then dividing by 9. The mean for a population is follows the same formula, so I'm copying and pasting. I haven't yet completed the standard deviations, but let me check whether I have made any mistakes or not. Okay, so these two are correct. So all I need to find is the standard deviation. Standard deviation for a sample is this formula, square root of all of this. For a population, standard deviation, the only difference is you don't have n minus 1. You have n. All right. That minus 1 is not there for population. So let's figure out for the sample standard deviation. So I need to first figure out summation x squared and summation x power 2. So let's pull up our calculator. All right. So I need first summation of x squared. Well, it might be better to first find that one. So let's see, 21 plus 25 plus 23 plus 15 plus 28 plus 40 plus 21 plus 36 plus 33. Okay, and I'm going to take power 2. Okay, 5, 8, 5, 6, 4. So what is this? Add all the x's, then take power. Add all the x's, then take power. So that is 5, 8, 5, 6, 4. And numerator is, you don't first add, you first take powers. All right, so that gets me 7030. All right, so with that in place, let me figure out, what does this say? It says square root, square root of an entire mess. So let me write down SQRT of an entire mess. What is the mess? It is a fraction, numerator over denominator. There are 9 numbers. 9 minus 1 goes in the bottom. What goes in the top? The top is a complicated expression, so place it in parentheses. Don't forget to place it in parentheses. The first number is summation x squared, 7030, minus the second number is summation x power 2 over n. So 5, 8, 5, 6, 4 over n, 9. So let me submit and check. Okay, it's not happy because SQRT is not allowed. So I understand. They don't want you to use SQRT. They want you to give the final answer right away. So let's look at our calculator, right? For the standard deviation, use the calculator, find the final answer, and then plug it in. So repeat, square root of something over something. So something over something, right? So what is the bottom? N minus 1. Remember, we have 9 numbers. 9 minus 1 is 8. What is upstairs? First, summation x squared, 7030, minus summation x power 2 over 9. So that is 58564 over 9. All right. So I get this number. Now let's see whether it's happy to accept it. So it's not allowing me to use square root of web work here for whatever reasons. So I simply copied this answer and pasted it here. Okay. Now let's check. Okay, it's happy. So for the population standard deviation, well, how is the formula different? It is no longer n minus 1, it is simply n. So I no longer have an 8, I have a 9 here. Everything else is the same. So that goes here. All right, so this is good. Now, so mind you, sometimes WebWork is willing to accept square root, SQRT, but sometimes it is not. So it's not a big deal. You can find the square root yourself and proceed. Next problem. If the average low temperature of a winter month is 16% and standard deviation is 4.6, then according to Chebyshev's theorem, the percentage of average low temperature between 6.8 and 25.2. So, all right, so let's figure this out. What are they saying? Average low temperature. So they are talking about mu to be 16 degrees. All right. And then they are saying standard deviation. Sigma is 4.6. All right. Then according to Chebyshev, let's look for Chebyshev. Chebyshev's theorem says, given any data for any constant k, right? So you have between mean and deviations, k standard deviations. Proportion of the data that must lie within k standard deviations on either side of the mean is at least 1 minus 1 over k squared. Okay, whether or not you understand this, but this is easier to follow. Between 2 standard deviations of mu, you get at least 75%. Between 3 standard deviations of mu, you get at least 88.9%. 4 standards, within 4 standard deviations of mu, you get 90. What does that mean? So 2 standard deviation, 3 standard deviation, 4 standard deviation. So that is mu, and that is 1 standard deviation. So let's figure out what is mu minus, let's see, one of these, because they mention Chebyshev's, I'm looking at either 2 or 3 or 4. So what is mu minus 2 standard deviations, right? So that is 16 minus 2 times 4.6. So where's my calculator? There you go. 16 minus 2 times 4.6. Oh, 6.8, precisely the left end point they are looking at. Okay, so good. So that is 6.8. So looks like we are talking about 2 standard deviations. All right. Now what about mu plus 2 sigma? That is 16 plus 2 times 4.6. What do I get? Instead of minus, I have a plus. I get 25.2. Oops, I'm sorry. Okay, here, 25.2. So plus 2 standard deviations is 25.2. Is that what they are saying? Yes. So what are they looking at? They are looking at 2 standard deviations around the mean. You go left 2 standard deviations, and then you go right, that's the plus 2 standard deviations. What does Chebyshev say? Chebyshev says at least 75% data fall in this interval, 2 standard deviations. So at least 75. Okay, so that completes section 3.2. Next videos will cover section 3.3. Until then, bye.